So welcome to the pre-recording of lecture 9 of Introduction to Symbolic Computation. This lecture has as topic persistent data and serialization. So we are going to look into how to preserve data, preserve after our notebook has finished executing. Um, we will see also why SageMath has kind of a different Python. And speaking of Python, in a way, this is not a programming course, but we will cover some of the topics that are very useful, in particular, file working with files. So topics that are actually very useful if you work with Python programs. Most of what I will explain are more or less independent of any programming language. So we are working with Jupyter Notebook, which allows us to do language agnostic computing. So if we want to save something on file, then the first option is to look at strings. So why do we may want to do this? We could copy an entire table of numbers inside a code cell of a Jupyter notebook, but sometimes the data sets are way too large, and also on the other part of the motivation is that often we may want to get into long computations and we want to store the results independent of the Jupyter notebook. Okay, so what is important is that every object has a string representation. If you program in Python and if you um, define a class for a new type, one of the very first things that you start to do is to come up with a string representation, which is equivalent of saying how would you print the object. Now, once you have a string representation, then you can write that string simply to file. So using the string representations is a very general way to store data. Um, so when you write, you first compute the string representation and then you write the string. When you load in an object, you first read the string and then you construct the object from the string representation. So that's the general way of working. Um, Now, Sage uses Python, but it has a layer on top of Python. So this is actually the preparse is the key uh, construction here. So whenever you type in something into a Sage cell, a Sage code cell, then it's actually pre-parsed. So the purpose of this lecture, it has a very um, basic purpose, so dealing with persistent data. But at the other the other goal is that you can see explicitly the intermediate layer that is between you and the Python interpreter. Um, from Python, we have the string method and the eval. So the string method converts an object to a string, makes the string representation of the object. The eval does the opposite. It takes a string and it kind of constructs the object. So in a way, you could see the eval as running the Python interpreter. So here we have a sequence of 3 statements. We could essentially see this as running these statements one after the other. So everything is typed, and the function type is very useful because the type will determine what operations that can be done on the object. So when you write 3, then 3 is the object that represents the integer number 3. So they are not the same because, as we've seen in an earlier lecture, and as you know from computer literacy, everything is stored in binary. So the number 3, the abstract number, is different from the object that is actually storing and representing the 3. Okay, speaking of representation, so we have the string method that is predefined for all the common objects. So this is not a programming class. You will not have to set up your own string representations, but you have to know that every object has a string representation. So the SX here is of type string, and you convert that string back to the object that represents 3 with the eval. So in some sense, string and eval are the counterparts, the opposites. Now, in general, for integers, that will not be so much different between Python and Sage. But know that Sage, and we know that already, that Sage has a much more elaborate number system. So we started out this course with making accurate floating point representations for constants such as pi. So what is returned there is that you have an MPFR real number. So if going to the string representation is simply not really any different, so the method that is there applied is the string representation that is provided by the wrappers to the MPFR real numbers that is provided to you by Sage. But if you do the eval on the string representation, then you would execute the eval from the Python interpreter. So what the preparse does, it prepares the string for the Python interpreter. So it takes the string, it recognizes that with the decimal that this is a real number, and it's going to wrap a real number, so the constructor of the real number class, it's going to wrap that around it. And then you still have to do eval, because the result of the preparse is another string, but it is a string that will provide the context in which the Python interpreter can evaluate the number correctly. So correctly means here in this example, correctly from within the MPFR numbers. Okay, so that's the first half, Python. Then there is more in Sage, and so there are now two alternatives. We've seen the two-step process, writing to string and then writing the string to file, reading the string from file, and then evaluating the string within the context. This is very general, and by the way, this topic is also useful if you want to interface with other programs not available within Sage, external programs. Now, the advantage of string representations are that they are readable, so even without Sage, you can look at the data. The disadvantage here is this two-string process. So also the preparse, if you forget it, like in the case of the real number, you will essentially lose the accuracy of the highly accurate, so 20 decimal places accuracy, because Python does not have a built-in multi-precision package. There are alternative multi-precision packages, but you have to install them separately. So there is the save method and the load function. So the save method is applied to an object, so you use the .save, and that writes an SOBJ file. So that's a file that you can look at, but it's not meant to be reading by humans. Now the counterpart is then the load function. So the argument of the load function is an object that was created with Safe, and then you assign, so it's a function, so the right hand side is what you assign then to a name of a variable. So only two commands that you need to know. It takes care of all the typing. You don't need a preparse, but it requires SageMath. Um, so it's important to share data within between Jupyter notebooks with the same SageMath kernel. So it's not suitable for interfacing with other programs. So that was, by the way, another application of saving data. You may have a very important data set, and you have very many different Jupyter notebooks that use the same data set. So duplicating that data set in all the Jupyter notebooks is highly wasteful and not really recommended. Okay, so then there is the Python approach, which offers an intermediate solution between the plain string format and what Sage offers with the Sage objects. So it converts the objects into a byte stream. So byte streams have the benefit of being efficient again, but byte streams are not meant for human reading. So how does this work? So there is the pickle module that you have to import. And for example, what typical object would you do? Well, you would, for example, take a list. So you would do this on an object that is provided by Python, but not so much by Sage. So there is then still a two-step process. So it used to be with Python 2 that you got a string representation out of there. When you pickle, actually, you do get a bytes type. So the byte stream is now provided in Python 3 by the bytes type. And then you still have to, before to write this to file, you have to convert the bytes to a string. So in that sense, the string then follows the general way of writing text strings to file and reading text strings from file in Python. Okay, plain text as data, Sage object, and then the pickling, the serialization. So these are the three tools that we have. We give the overview of all three in the hope that you may remember at least one. So in this remaining part of this pre-recording, I will switch to the Jupyter notebook, and I will demonstrate the three types in which you can work with persistent data, so outside your notebook. So I will do this with Jupyter notebook in three sections. So I started out with an untitled notebook. So here I clicked on New SageMath. So this is my kernel. If you are new in joining, then this is one way of working. The other way is to work via CoCalc, and perhaps I will do this now because on my computer I know where the files are and I know where everything is, but I'm kind of curious where everything is on the cloud. So let me make a project. So I do not have an account for Sage, but everything actually does go fast. So this is the MCS 320 lecture 9 for the recording. So I will create the project, and once you create the project, you have to start it and select a kernel. So here it takes a while. We will in general not do many computationally intensive jobs. Here I could create or upload files. If you have any troubles with doing that, or perhaps I should demonstrate this. So I will upload a file. So create or upload files. So I can upload by uploading from my home folder. So this is already lecture 9, and I have the Jupyter notebook that is sitting in there. Alright, so this has the advantage that I don't have to do too much typing. It has the advantage also that I can just verify whether my posted notebooks are fully compatible with the version that is run in Sage. Okay, so I upload. I'm kind of thinking now that I have to click on a button, and it is here. So yes, indeed, it is loading. Very good. All right, let me go back to my notebook that I will make during this recording. So it's good practice to start with a brief Markdown cell. We are going to introduce saving and loading data. And we're going to do this in 3 ways. So first we do this with a plain text. So essentially we do this with strings. So let's take 20 decimal accurate or a 20 digit decimal digit accurate approximation for pi. So that will be our running example. So we practiced this command multiple times. So we have the x here. So this is our long number. The way to do this is to compute the string representation. And perhaps to be pedantic about this, I will explicitly make the types. So when you print it, you will not see the difference. So you see just the same, but there are different objects. So the x is an MPFR real number, the SX is a string. So now I can write the string to file. So how do I work with files? So I do the open. F is a file name. So this is my number x. So let me call this pi 20x, It will be a text file, so I will open for writing. That's the one statement. So it's, you can put everything in one cell, but if this is the first time that you execute it, you may want to do this one after the other. So the f is an object, and I can write to this. So I can write the string to this, and it wrote 21 characters. And then it's good practice to close the file. Okay, how can I see this now? I can of course go to my folder and I should see it there, so that's one way to do it. But I can do it from within my SageMath session by listing the directory. So, and what I'm executing now is the and here you see it. So I have the Py20x sitting in there. So Python, with its operating system module, allows that you list the directory, list the content of a folder within a Python session. So if you are executing this now on a Mac, the directory listing will be another command. If you do this on a Linux system, it may still be something different. So the directory listing can be obtained with one single command. Okay, let me go now to the prepared statements and execute this in the CoCalc session. So here I did everything in one. So let me see if it went through. So it's still running, but I can continue this. And I want to get to the point where I see the directory listing. And yes, it actually shows my folder. And what it should show is the my data. So I called it my data, and indeed my data is here. Okay, so how do we check whether this is fine now? Well, the purpose of loading, saving things, is that you can retrieve things. So let me go back to the work notebook that I was recording. So to sum up what we just did, we saved the string representation of the number x to file with name. I called it here Py20x. So it's a plain text file. Okay, I can reset x. So I can also declare x as a new variable, but x is already something that is predefined. X is so common as a variable that you do not need to declare it. So I've lost the approximation for pi. Now in this case there's no problem, we can immediately recompute it. But let us now retrieve the number from file. So let us retrieve the number from the file Py20x, the text file. Okay, so there is the f that I closed. I can open a file for reading. So I have to give the name of the file, txt. Now, by default, this is the current directory. So it's also essentially good practice if you would have a big project with one important data set that is shared with many people, then you may have to open the file somewhere at another folder on the file system. Then you must provide the absolute path name. Okay, I will open the file, and this went immediate. So if the file is not there, then you should have an error. And then I can read from the file. I can read byte by byte, but I can also read all lines. So let me do this. So I will read lines. So what this returns is a list of one list, so a list of one item. So I have my number sitting in there. So if you like, this is the SX, is the content that I got from read lines. So what I have is the string. So if I print it, I will not see the single quote. So it's good to do the SX. So it tells you actually the quotes that are around it. Tells you that it is not a number. You can't compute with this, or well, you can do some operations on this, but not compute in the literal sense as we understand as computing with the number 3.1415, etc. Now, we need to pre-parse this, otherwise we will lose. So let me pre-parse the number. Let me do this correctly. So here you see that within the context of SageMath, then this is a real number of arbitrary precision. So in previous lectures, we defined real fields with a precision of a certain bits. Here what a real number does, it is a constructor. It will make a real field of the required precision. So let's do this. So we will evaluate px, and let me print out the x and also the type of x. Okay, so if you use this method, this is a very general method. It also shows explicitly how to work with files. So when you work with files, so I should still do one more thing. I will close the file for reading. So I no longer need the file. So closing the file means that I can use the letter F for something else again. Okay, so this is a recap. Before I forget, do not forget to use the preparse. Otherwise, a premature evaluation will result in a loss of accuracy. So let me demonstrate this. So I will evaluate the SX directly. Then you see I'm doing the eval of float. So I'm then casting the string, I'm converting the string in a double precision number. And this is actually not what we want. So the eval applied directly to the string representation of x results in a double float of Python, not a multi-precision real number. Okay, so let me now recap to see whether this is also happening, working all very well from within the cloud. So also there I have a current working directory, and I can read from file. So I read from file here, just reading one line, and if I read one line, then so read line is a little bit more appropriate in this context because I have only one line. Read lines is more convenient if you have multiple lines on file. Okay, so I could convert immediately to float, and that is actually what the eval does. It is not different in using the RR. And it's also not different of using the eval. So in the prepared Jupyter notebook, I started with all the wrong ways how to do it. So the correct way is to work with the preparse. So if you preparse, then you have an intermediate string that you can then evaluate within the context, within the proper context. And now we see that we have the full 20-digit approximation of pi. Okay, so this was the long way, and actually the most general way to work. It's a little bit cumbersome and also prone to error if you forget the preparse. So if you want to share data within the Jupyter notebook environment, we have the saving and loading SageMath objects. So the save is a method that will do both steps all at once. So the save method converts to a .sobj file. So I still have my x here. So I'm going to save this to my xpi 20, and well, I think this should be good. So I had pi x, but let now 2, so it's not. So, and I don't place an extension to this, so I do x save. Let me now check what happened. So I save the file, so I'm going to import OS again, although I imported this already, so that might not be necessary. And let's look at the current directory. And now you see that next to the pi 20x, I have the pi 20x2, and it has added the sobj extension to this. So I can read, I can look at it, but that is not recommended. And we can do the same. So to look at this file, so we see that the pi 20x2 sobj file is present in the current folder. We could look at it from within, so this is actually a good exercise. As an exercise, open the file, read the data as a text file and look at it. So I will not go there, so that's an extra exercise here. Instead, I want to make the point, why would you want to use save? So the point of using save is that there is only one action, only one step for saving, without the intermediate string representation. And moreover, also the loading of the data happens in one step with the load function. Note the difference between a method and a function. A method is applied to an object. A function is applied onto argument. Okay, so to make the point here, I will clear the variable x. So that means that I'm assigning to x a variable name. So I used the reset before. A bit more general is to declare a variable again. So this is another Python way is to delete. I will illustrate that later. So I have lost the content of x. I can get the content of x by loading from the file py20x2. And let me also forget about the extension here. So let me load it and let me then print x. So, and the type of x, the type of x is a real number. So to recap, so this session, so this demonstration, I'm kind of stretching it. It goes on, but it's actually only 2 commands. So the conclusion is that for SageMath objects, the save and load are recommended for working with data. Because you save the data. Sage knows, I mean, you save the data, of course, but you also save the additional type information. Okay, so then there is the third way of working, which brings us back to Python. And in Python, you can pickle objects. So pickling is the term that Python uses for serialization. So what is serialization then? Well, serialization turns an object into a byte stream. So it is similar to the string representation, but a byte stream is again not really meant for human consumption. The advantage of now using the pickling is that it stores also the type information. Again, so two differences with strings representations. So the first difference is that byte streams are not human readable, and the byte streams include the information about the data type. So in some sense it depends what you really want. Strings are very convenient if within the context they can be interpreted very naturally. So there is unambiguously, there is not really a discussion of what is an integer and what is a floating point number. We see it with the decimal point. Now, if you want to store more complicated data types, and then the string representation might not be convenient. The string representation could be very general, so it's human readable, and any programmer can do something with this. All right, enough talk. So I do have my X again. So here is my running object. So I will pickle it. So I will import the pickle module, and I will pickle X to make a dumps. So here you see that it is a byte stream. It's actually not really readable, but still it is readable in the sense that the pickling of Python has actually retained the real number information. So you could still read it. The little b up front here illustrates that this is a byte stream, and you can't really write this directly to a string. So important here, it is important that we cannot write a bytes type object directly to file. We must convert to a string. Okay, I will convert then this to a string by applying the string method to this. So let me verify that everything went well. I will open a file with name x or pi20x, and now it's the third object. I will open this for writing. And now perhaps, again, it's not strictly necessary, but let's say that this will be a text file. So I have to apply the open method. So I will open a file. I will write to file the string. So it's good to do this. Here you see the number of characters that have been written, and then I will close the file. So it's good practice to actually verify whether everything went well. If you forget the closing, then it might be that you don't see the file there, but here we see the pi20x3. Okay, it's written to file. Let me now remove or delete x. So, oops. So I will delete x. So that's we are in the Python world now. So delete also supposed to kind of deallocate explicitly. So and now you see that x within this context is actually not defined. Okay, let's now do our retrieval. So the retrieval consists in opening the file. I closed it, so now I'm opening the file pi20x3. It's a text file for reading. I will read a line, so there's only one line on this, so I will read line, and let me also print it. You see, it's quite explicit now. It's very convenient that we see the double quotes. So line has type string. So just to make sure it's a string. I cannot yet parse it, so I have to convert this into the byte string. So before we can continue, so the first step now is to convert the string into a bytes type. We apply, so this is now a moment of suspense. So what was the counterpart to the string method? Well, we apply eval. So let me do this. So this is the evaluated line. So I will apply eval to line, and let me print explicitly that this e line has the type that type says that it has. So now we have types, um, um, a byte type. Okay, we did the dump. We do the load s from the pickle module. So let me do pickle load s from the evaluated line, and that gives us the number pack. Okay, so that's it. Um, so we saw the important ways how SageMath differs from Python. We also recovered some important Python, so how to work with files. This is not a programming class, but in a computing class, this might be useful if you ever work with an important large data set, um, or if you compute data that you would like to save for further usage, then you use files. Okay, so thank you for watching. I hope this was interesting.